Now that you've collected some clay samples, I want to show you some basic tips on how to process and then test those clay samples. We want to see what its working properties are, as well as its fired properties. See what its strengths and weaknesses are, how you might compensate for those, and ultimately, what this material is good for. These are some tools that you'll need: a bucket, some clean water, and optionally a drill with mixing attachment, screen or sieve, and a pillowcase. The first step for processing would be to let your clay completely dry out or get dehydrated. You could just let it sit out in the sun or in a warm place, but we want that clay to be completely bone dry. What that allows us to do is submerge this in water, and the particles will slake down. Any organic material might float to the surface, and we can take that slurry and pass it through a sieve if you have one available. This is some clay slaking over a half-hour time period. Now that I've let that clay slake down, I could agitate it with a drill with a mixing attachment to break up any stubborn parts. But I don't think I really need to. This has broken down pretty well. And what I'm going to do is pass it through a sieve or mesh. And this is going to help screen out any bits of organic material, bigger chunks or pebbles that might be in there. This is about a 40 mesh screen, and I'm just using a rubber rib to kind of force that material through. Again, if you had like a section of a window screen, that's probably a little bit bigger mesh, but even that might be worth using as like a kind of a basic sieve to get out roots and bigger pebbles. Having a tool like this or even a scrub brush to help force that through is useful. Now that I've sieved this material, I've got a fairly watery solution. And you could just allow that to sit, and in this example, the water is going to start to separate out, and the heavier particles will settle to the bottom, and you can siphon off some of that excess water. That's going to take some time. If you had access to a plaster slab, you could pour this watery solution into that, and it will act as a rigid sponge, sucking the moisture out and also giving it plenty of surface area to evaporate. Another option, if you don't have a plaster slab handy, would be to use an old pillowcase. I'm going to set that pillowcase inside of a bucket. And pour my mixture in. You can squeeze some of that water out, or you could just tie this up. Oh shit. or you could just tie this up and let it dry slowly. Now that most of the water has been absorbed, I'm going to go ahead and try and scrape this off, see if I can get plastic usable clay. Once you have your processed clay, you want to do some basic tests to determine the working properties. I'm just rolling a coil to test for plasticity and bending it, and it doesn't crack, so it's pretty good. Now I'm going to set that aside and make a pinch pot. This will help me determine how malleable it is and what the texture of it really is. Will it hold its shape? This is an example of that raw locust beach clay, unprocessed. This is an example of that just bisque fired. And this is a brick that is from the Brennan Pond area, so material that was made from this type of clay. I also have here test tiles from two very similar clays. These are from Brennan Pond in increasing temperature, and these are from Discovery Park, which is a park with an exposed clay bluff down by Seattle. So both of these are indicative of that Lawton clay formation that covers the Puget lowlands. So what is this clay good for? Ultimately, probably bricks. But you could make a serviceable low-fire terracotta using it, and you could even use it as a slip or glaze. This was painted on a piece and fired to cone 6. It does, unfortunately, have this kind of crawling problem that's common among slip glazes, but at different temperatures, it might have different uses. Or you could just tie this up. Oh, shit.